Section 4.3, multiplying polynomials. Our objective today is going to be to learn techniques to multiply polynomials. First, our rule. Think of multiplying polynomials as the double or triple distributive property, or by using what's called the box method. Now, when we're finding the product of two binomial expressions, we can simply use what's called the FOIL method, but we're going to prove later and see that the FOIL method is really the same thing as double distributive. FOIL method stands for first, outer, inner, last. It's an acronym. Example 1 says, if I of t represents the current function and r of t represents the resistance function, then find the expression to represent a voltage function. And these are clearly made-up functions. These are not real functions for resistance and current, but we're going to take a look at an example of this. Now, the voltage function is represented by the following relationship. The voltage is the current function times the resistance function. Well, here in blue is the current function, and here underlined in black is the resistance function. So the product of those two functions is really going to be our voltage function here. So what we want to do here is find the actual voltage function first, and then go on to find the current, resistance, and voltage at 2 seconds, or when time is equal to 2 seconds. So first we have to think about, all right, let's take a look and apply this rule that the voltage is equal to the current times the resistance. Well, the current is the following expression, 2t to the third plus 4t minus 6. And the resistance is t to the third minus 2t to the second minus 5. So we're going to be multiplying these two things together to give us the voltage function. Okay, that's what the voltage function is. Now, the key to remember here is that, as we said earlier, this is just like a distributive law, but instead of distributing just the coefficient, we distribute everything. So let's think of this whole thing here as like a coefficient in front of this term. If we didn't have these two values here, and we just had the -6, we would take the -6 and distribute it to every term. But we're going to do that for every single one of these now. And we're going to see that we're going to have 9 results that we have to then combine like terms for. So let's start with this first part here. Let's distribute this to all 3 of these. As a result, we're going to get 2t to the 6th. That's the 2t cubed times t to the third, giving us 2t to the 6th. We add the exponents, and we multiply the coefficients. Next, we have 2t to the third times negative 2t to the second. So 2 times negative 2 is going to give us -4. T to the third times t to the second is t to the fifth. So this is going to be, again, -4t to the fifth. And then finally, 2t to the third times -5 is just going to be coefficients being multiplied to give us -10, and then the t to the third carries over. So remember, you're always multiplying your coefficients and you're multiplying your variable parts. You're not mixing them together. Let's go to the 4t next and distribute it. We'll distribute 4t to these 3 terms, again, the same way we distributed the earlier term. So the first time we did it was the first distributive. This is the second distributive, and then when we distribute the -6, we'll see that this is an example of triple distributive. So we take 4t, this first part here, times t to the third. Well, the 4 times the 1 that's here is still going to give us a 4. T times t to the third is t to the fourth. So plus 4t to the fourth. Then we have the 4t times -2t squared. That's going to give us a -8 in the front. And then we have t times t squared is t to the third. And then finally 4t, again the same quantity, 4t times this -5. 4 times -5 is -20, so it's -20 times this t. And then finally, the last part we want to do is distribute the -6. So let's take this -6 and distribute it to each term. Well, the first two are easy. It just becomes -6t to the third, and then the -6 times -2 is 12t to the second, plus 12t to the second. And then at the end here, we're going to see that we have a -6 times a -5, which is a positive 30. So it's just plus 30 at the end here. Plus 30. So this is our voltage function. Notice I used the red to indicate the first distributive, the blue for the second, the green for the third. But now we have to go ahead and look for our like terms. So I'm going to underline the like terms now. There's only one that has t to the 6th, and that's this. Then I go to t to the 5th. This is the only one t to the 5th. This is the only t to the 4th, but here's t to the 3rd, t to the 3rd, t to the 3rd. So these are all like terms. T to the 2nd only occurs here. t to the first only occurs here, and then the constant term only occurs once. So there's only one set of like terms, okay, or one triplet of like terms really here. So everything else just gets carried down. So 2t to the 6th minus 4t to the 5th. Now we combine our now we bring down, let's cancel those or show that we used those already. Then 4t to the 4th. Now we bring down our t to the 3rd. So we have negative 10, and negative 8 is negative 18, and negative 6 is negative 24. T to the 3rd. Then we've got 12t squared. It's going to come from here. We've got a negative 20t, and then finally a positive 30. And this again is equal to our voltage function, v of t. So that is our voltage function from highest degree down to lowest degree. Notice as t to the 6th, and the voltage function was equal to the product of something that was t to the 3rd and another thing that was t to the 3rd. So the highest exponent should be t to the 6th. So that is indeed our voltage function using double or triple distributive method. Now we can also do the same thing using what's called box method. So let's remember this answer we got, and let's go ahead and use box method. So for box method, what we want to do is we want to think about the fact that our first polynomial, our first factor, was this part right here, which has 3 terms to it. 1, 2, 3. And this one has 3 terms to it also. So we start by making a box. And that box needs to be big enough to fit however many we have across the top, term-wise. So let's start with 2t to the 3rd. That's the first column. Second column is a 4t. And the third column is the negative 6. So again, we've pulled all 3 of these terms and put them in the top. And we're going to take these 3 terms up here, and we're going to put them along the side for our rows. So we're going to clearly see that we also need 3 rows. So this looks kind of like our matrices that we did with 3 by 3 and 3 by 4, but it's not a matrix again, it's just a table, that's all this is. So t to the 3rd, negative 2t to the 2nd, and finally a minus 5 at the end. And what we're going to do is just simply do the same thing we ended up doing. Notice there's 1, 2, 3, 4, 5, 6, 7, 8, 9 terms that we're going to have to fill in. There are 9 terms here. Just like our answer earlier, we had 1, 2, 3, 4, 5, 6, 7, 8, 9 terms. And we had to combine those like terms to yield this polynomial function. So let's go ahead and take a look. We're going to multiply this term times this term to give us an answer here. And notice that's what's going to show up from this part right here. So this when we did 2t cubed times t cubed, we got this answer. Then we did 2t cubed times negative 2t squared. That's going to come from here times here, giving us this answer. So these 3 are really these 3 in order. Then these 3 next are these 3 in order. So it's the same answer, it's just an organized graphical way to look at it. The other way we did it was just with double and triple distributive, which is the same thing except it can get a little bit messy. So we can go ahead and simply multiply all these, giving us 2t to the 6th, negative 4t to the 5th, and this is going to be negative 10t to the 3rd. And again, notice that those 3 numbers, or those 3 expressions, are the same thing as these 3 right here, except they're written this way. The next thing we're going to end up getting is going to be 4t to the 4th minus 8t to the 3rd, and this is going to give us minus 20t. Finally, at the end, we're going to have negative 6t to the 3rd, 12t to the 2nd, and 30. Noticing that all 9 terms are the same 9 terms that we had earlier when we used our triple distributive law. Now all we need to do is go ahead and sum these together, and what we'll notice is that our like terms appear along this diagonal here. Okay, and a lot of the time, if you put things in the correct order and you're not missing spots, you'll have a lot of diagonals occurring with like terms. Here we only have one set of diagonals with like terms, simply because we're missing a t squared over here, and we're missing a t part over here. Okay, notice we go from t cubed, t to the 2nd, there's no t, that's what's missing right there. So we're not going to have a lot of like terms in these problems, or in this problem exactly, because we're missing some of the terms in our polynomial function. Anyhow, let's add together those 3 like terms. That'll give us negative 24t to the 3rd. Well, that's this right here. And the rest of this problem, we're just going to simply add everything together. Well, we can't add any of these. None of these are like terms. So the same answer appears that we had earlier right here. Okay, so this is still the same exact answer we get from box method. But remember, box method is the same thing. We're just adding all these up separately. I added these 2 together to show you this comes out, but the rest of them just get carried down because there's no like terms for anything else in this problem. Now the rest of the problem said to find I of 2, to find R of 2, and then go ahead and find V of 2. So the resistance, the current, and the voltage when time is equal to 2 seconds. So we're going to go ahead and list our functions one more time. Now what I want to do is take a look at the first two only, and we'll talk about this v of t in a moment, why I left that blank. So if that's I of t and we want to see what I of 2 is, it means we're just plugging in a 2 for time. So plug in a 2 here, and plug in a 2 here. If we do that, we're going to get 2 times 2 to the third, or 2 times 8, which is 16, plus, this is going to be 4 times 2 is 8, minus 6, that's going to be 24, minus 6 is going to give us 18 for the current at 2 seconds. The resistance after 2 seconds is going to become 8 minus, let's see, 2 times 2 times 2 is 8, minus 5, which is going to give us negative 5 for the resistance. Now, we have the current and we have the resistance. If we go ahead and write all the voltage function out and then go and say, what's v of 2, we'll get an answer. And it's going to be some work to do that because there were a lot of terms from the voltage function. We could also just remember that we had the following relationship from the beginning of the problem, that the voltage was equal to the current times the resistance. Remember, this voltage function came as a product of these two functions earlier. So if we just take these two quantities and multiply them together, that'll also give us v of 2. So we don't have to do any of that work, we just get negative 90. You can go ahead and check and plug 2 into the voltage function, but you will indeed get negative 90. Example 2 says if h of x equals 2x minus 3, g of x equals negative 3x squared plus 4x minus 2, and u of x equals 4x plus 2, then find the following. So let's take a look. First one, we want to find double g of x times u of x. Well, if we remember that multiplication is commutative, we can go ahead and simply multiply this first. If we want to make it easier, let's just do g of x times u of x and then multiply that answer by 2. Okay, now, in this case, I could use box method or I could use distributive. I'll go ahead and choose to use box method. So I'll start with g of x, and I'll list that across the top. Here's g of x, negative 3x squared, positive 4x, and a negative 2. Those will be my columns right away, I know. Okay, I know I have 3 columns right away. Then for u of x is just 4x plus 2, so 4x plus 2. So in this direction, I'm only going to have 2 rows. So notice how many entries? 6 entries. Again, because there are 3 terms here and 2 terms here. That's why there are going to be 6 entries total. And then we'll see that we can add like terms. So let's go ahead and look at this example. So we start with negative 3x squared times 4x. Negative 3 times 4 is negative 12. X squared times x is x to the third. So negative 12x to the third. Then we do negative 3x squared times 2. That's going to give us negative 6x squared. 4x times 4x is going to give us 16x squared. 4x times 2 is simply 8x. Then finally, negative 2 times 4x is negative 8x. Negative 2 times positive 2 is going to give us negative 4. So what we're going to do is notice again, diagonally our like terms appear. Diagonally our like terms appear. So we start with our first unlike term, which is negative 12x to the third. Then we say we have 16 and a negative 6 is a positive 10x squared. These cancel each other out, negative and positive, and then we just have a minus 4. So this is our answer for part A using box method. You can go ahead and try it using double or triple distributive depending on the order in which you put the factors. Now, we have to remember that this is not our final solution for part A. For part A, we still have to multiply this by 2. So let's double our answer here. So again, we could have doubled g of x to start and then multiply that by u of x, but we did g of x times u of x and then multiplied by 2. Again, because of the fact that multiplication is both associative and commutative. So our final answer for part A, we'll put it in red, would be this. Negative 24x to the third plus 20x squared minus 8. Now let's take a look at part B. Part B wants to do h of x times u of x. They're both binomials, so this is where we're going to take a look at FOIL now. So let's go ahead and write this out. So for part B, h of x, that's 2x minus 3, times u of x, which is 4x plus 2. So we're simply multiplying these. Now, what I'm going to do on the side is this. I'm going to write down FOIL, and remember what it means. First, outer, inner, last. Now, what I want to show you, though, is if we use double distributive, and remember, we distribute these, okay, first, and then we distribute these after, like that. It's really what FOIL is. So let's take a look. first. First means to take the first two terms of each. Well, that's the same thing as just multiplying using double distributive in the beginning. So distribute this to here. These are the first terms. 2x times 4x is 8x squared. Then we go ahead next and we take a look at the 2x and we multiply by this part. So we're multiplying these two. Well, that's what outer really means. The outer parts. 2x times 2. Well, that's just going to give us 4x. Then we go ahead and start with the negative 3 and distribute it. First distributing it to the 4x. Well, this is the inner part of FOIL. That's what they're saying for inner. So the inner parts are right here. They're on the inside. Negative 3 times positive 4x is going to give us negative 12x. And then finally, we would take the negative 3 and distribute it to the 2, giving us negative 6. Well, that comes about from the last part. Last meaning the last terms of each. So FOIL is really another way of looking at the double distributive law. Doesn't matter which way you remember. Personally, I've always used double and triple distributive, but I also knew FOIL when I was younger. I remembered that. But it makes no difference either way. Let's just simply combine like terms and get a solution here. So it's going to be a minus, not a plus, right? Because the negative 12 is larger. So we're going to have a negative 8x and then a minus 6. Now, before we look at part C in the actual solution, let's take a look at how it's similar to parts A and B. Well, part C is asking us to do h of x times g of x times u of x. Well, we already did g of x times u of x. Right? We did this and we got this answer right here. So we could replace this part with this entire thing. So here's what I want you to notice. This was already completed in part A. This is right here. It's already listed. So we can just take h of x and multiply it by the result that we got from part A instead of doing it again. Okay, or we could have technically said this. We could have said we had h of x times u of x from part B. We could do this and replace these two and get rid of them and then multiply the answer we got from the last part by g of x. But it's easier, I think, to replace this with what we got from part A, and then we'll just multiply that by h of x. So let's take our answer, or let's take a look at part C, and remember that it's h of x, okay, and h of x in this problem, if we go back up and look, is 2x minus 3. And then we're taking h of x, and we're multiplying it by g of x times u of x, which is this quantity right here. Okay, we already did that at the table. So I'm going to list this down at the bottom now because we're going to be using that. So we've got negative 12x to the third plus 10x squared minus 4. And now what we'll notice is that we simply have to do one set of distributive instead of a distributive and then another one. So if you get an answer earlier that you can use for the later part, please go ahead and do that. Don't take more time for no reason at all. So we'll start by distributing this part first. And then we'll move on and distribute the negative 3 to these three terms. Let's take a look at what that produces. We're going to get 2x times negative 12x squared is going to be negative 24x to the fourth. 2x times 10x squared is going to be a positive 20x to the third. Then 2x times negative 4 is negative 8x. Next, we're going to take negative 3 times negative 12x to the third. That's going to give me a 36 x to the third. Negative 3 times 10x squared is going to be negative 30x squared. And then negative 3 times negative 4 is positive 12. Let's underline our like terms. I see a like term here and here only. Everything else is by itself. So let's list the things in order. Well, this is by itself. Negative 24x to the fourth power. That's what we start with first. Then we're going to move on to the third power. We have 20x to the third and 36x to the third is going to be a positive 56x to the third. Then we go to x squared, that's a negative 30x squared. Then we go to x as a linear term, that's negative 8x. And then finally the positive 12 at the end. Remember, as you're going through these, you can cross them off to remember, so that you're done with that, then you go squared, then you go linear, then you go constant. But in the end, this is our result for the product of all three functions, u of x, h of x, and g of x. The next thing to take a look at are some special cases. And what I'm going to do is I'm going to take a look at the rule and the examples, but I'm also going to show you for some of these how the examples work out. So for example, let's start with this one. If you are given this problem right here, and you wanted to multiply it, you have to remember to do this. Okay, and that's the first key. You have to remember that whenever there's a squared binomial, you cannot distribute the squared. You cannot do this. You can't move that and distribute it to both of them. Okay, again, you cannot do that. We have to remember that that is against our rules. We can only distribute an exponent if this happens to be a product. So if this was like 3x in here and it was squared, then the 3 becomes squared and the x becomes squared, but not when we have a sum in between here. So when there's a sum in between here, it's a binomial being squared, which is like saying multiply it by itself. So you would use FOIL or double distributive. So this would result in the following. The first term would give us 4x squared. Well, that's this right here, okay, according to our answer. And the outer term would give us a positive 10xy, then another positive 10xy from the inner term. And then from the last term, we'd get a 25y squared. Okay, 25y squared. We'll take a look. The two middle terms add together to give us 20xy. That's this part. And the last term is just going to be right here. Well, how does this apply to our rule? Let's take a look at what our rule says. Our rule says if we're ever given an equation or an expression that has to be squared and it's binomial, we can use this rule right here. Now, I really don't encourage you that you have to memorize it, but it is useful when it comes to factoring, when you have to go backwards. So for example here, what you'll notice is that if you just simply square this to start, that's what you get here. If you go ahead and multiply these two quantities, that's what this says here. This says to do 2 times a times b. So whatever's here and here, multiply them and then double it. Well, multiplying these two gives you 10xy, and then double it, that gives you 20xy, because it's like you're combining the two middle terms there. And then finally, the last part here is saying to square whatever shows up here. Well, that's because it's going to be 5y times 5y in the end. That's where that square part comes from. So you could remember this rule and just apply it. So for example, let's apply the rule for the second one. The second one is really messy to FOIL out. So we could remember that this first term here is going to be the square of this. So 3x, that quantity squared, is 9x squared. Because remember, this is indeed a. This is a, and we need to square it. So if you square the quantity 3x, it's like saying square the 3 to give you the 9, and then square the x to give you the x squared. So we're distributing that squared because this is a product here. Then to get the middle term here, we're going to take a look and we're going to say, well, the middle term comes about from multiplying a and b and then doubling that answer. So let's multiply these two things. Well, when you multiply these two, it gets a little bit messy here. There's going to be an xu for sure, and that's where this xu comes into play. But then we have to multiply our coefficients. So this 3 times this negative 2/5, that's going to give us negative 6/5. But negative 6/5 times 2 is negative 12/5. So again, this middle term comes about from multiplying the first and the last part of the binomial and then doubling that answer. The last term that you're going to get here is to take whatever the b value is and square it. Well, what we should notice here is that the b value in this problem is this entire expression right here. Okay, so let's take a look. It really is negative 2/5 u. So if we square that, though, the negative part really doesn't matter because we're squaring it, so we don't have to include that, okay? Because, again, this is really just saying b squared. So technically what I should have written down is this, okay? Because b is really just 2/5 u. But if we go ahead and square this, we're going to see that when we square 2/5, that really just gives us 4 over 25. That's this part right here. And then squaring u just gives us the u squared right there. So the second special case we're going to look at is called the difference of two squares. And the reason we call this the difference of two squares is because the product of these binomials always yields two squares and the difference here. So let's take a look at the first example, x plus 4x minus 4. If we use double distributive or FOIL, we'll see that we'll get x squared minus 4x plus 4x minus 16. And what we see is that these middle terms will cancel out, yielding simply x squared minus 16 as a result. So the rule that we can remember is that whenever we're multiplying two binomials that are complex conjugates, we get a result that is the difference of two squares. Now, by the way, a complex or a binomial conjugate is a binomial that's a plus b and then a minus b. These are conjugates of one another. They have switched signs in the middle here. Okay, those are called conjugates. So we'll see in the next example here, u squared plus 4, u squared minus 4, those are binomial conjugates again. So the result is just simply whatever these two multiply to give us and whatever these two multiply to give us in the end. So u squared by u squared is u to the fourth, and then 4 by negative 4 is negative 16. We don't have to go through the whole process of distributing. Same thing goes here. This would be really messy to do. So simply multiply these two to start, giving you this, and then multiply these two after that. Now, please note that there's a typo here, and this should say k squared here, and that should say k squared. Your homework for this section is from 4.3 and then a review from 3.2.